Now, let's briefly talk about a class of compounds called lipids. Now, lipids actually are an umbrella definition for a whole bunch of different, basically nonpolar or more soluble in nonpolar solvents than they are in polar solvents, compounds. And yes, I know I made a whole bunch of biologists really twitch by saying that. We're taking this from a chemistry standpoint, not a biology standpoint. Now, within the lipid class, we're going to look at one specific type of lipid, and these are fats, specifically triglycerides. So, triglycerides are made from the ester condensation of triglycerol. So, propyl backbone with 3 OH groups attached to it, so a 1,2,3 propane triol, reacting with some form of carboxylic acid. And we'll get into why these carboxylic acids matter. What they're ultimately going to do, and what you should be able to predict here, is that if we're able to remove the water, we end up producing basically a triester. Now, if this R group is saturated with hydrogens, means that we don't have any alkanes or alkynes along the branch, this is considered a saturated hydrocarbon. If there are alkenes and alkynes along the branch, this would be considered an unsaturated hydrocarbon. Now, this is not the only way we can produce them, because if you remember, if we have a carboxylic acid, we can also do this with the anhydrides as well. So if we have the acetic anhydride equivalent of this propane triol, we can also get the exact same reaction. The thing is that instead, in this case, where we produce water, we'll actually end up producing acetic acid in the process. This is the big picture aspect of looking at lipids. Lipids contain these triester complexes and are generally made, or can generally be, since this is a reversible reaction, be used to make your 1,2,3 propane triol and whatever starting carboxylic acid you had.